Okay, question number 1, it's looking for the domain. You're looking at your denominator. You're gonna take your denominator, 4x minus 3, and set equal to 0. And we're solving for x. So we add the 3 over, so we get 4x equals 3, and then divide both sides by 4. So you get x equals 3/4. Now, your answer is gonna be A, and it says x is a real number, and where x cannot equal 3/4. So our solution is what's going into the box. Number 2, again, it's asking for the domain. So you're again going to look at your denominator. You're going to take your denominator, x cubed plus 8x squared minus 9x, and basically you're setting it equal to 0. They both notice that they all have an x in common, so you're going to factor out an x. So we have x come out, and then we get x squared plus 8x minus 9 equal to 0. When you get to this point, you are going to factor out the second parentheses. So you're going to do 2 parentheses equal to 0. You're going to find numbers that multiply to be -9 and add to be positive 8, because positive 8 happens to be the middle number. So remember, to be 9, you can be 9 and 1, 3 and 3, but the only ones that can get you to 8 is the 9 and 1. So I'm going to write x and then a 9, x and a 1. Notice I did not put the signs because it needs to multiply to be -9, but a positive 8, one has to be positive, one has to be negative to give you to positive 8. So the 9 had to be the positive number, the 1 had to be the negative number. After you have your 3 pieces, you're going to set each individual piece equal to 0. So we're going to say x equal to 0, x plus 9 equal to 0, x minus 1 equal to 0, and then you solve for x. So this is still x equal to 0, there's one answer. This is now x equal to -9, that's your second one. This is going to be x equal to positive 1. There's your third one. So we actually had 3 possibilities where the answer cannot be any of those 3. So we are going to be, again, option A. And then you're going to go from least to greatest when you put it in the box. So -9 needs to come first, then a comma, then the 0, then a comma, and then a 1. Number 3, they want you to simplify the rational expression. So we have a trinomial sitting atop another trinomial. So first thing you do is you're going to number them 1 and 2. So we're going to work with number 1 first. It says 3x squared minus 8x minus 16. So first thing you want to do is see if they all have a common common GCF. 3, 8, and 16 do not. So we're going to go Colombian method. You're going to immediately draw 2 parentheses. And that 3 that's the leading coefficient, you're going to write that into the parentheses of each box. So 3x, 3x. Then you're going to take the first number times the third number. And I get 3 times -16, that is -48. So those 2 numbers gave me -48, and they need to add to -8 because -8 is the middle number. So then you're going to write your factors of 48. We have 6 times 8, 2 and 24, 4 and 12. We did a 3 and 16. You're going to come up with 2 numbers that are going to give you 8. Well, if I do 4 and 12, I can get to 8 because one had to be positive, one had to be negative. So you're going to write a 4 and a 12. For them to give you a -8, the 12 had to be the negative, the 4 had to be the positive. Then you're not done yet, so you need to reduce the second one by 3 because technically it does not exist. So we become 3x plus 4, and now x minus 4. That's the first one broken out. Then you're going to go to number 2. On number 2, it said x squared minus 5x plus 4. So you're going to go numbers that multiply to 4 that add to -5. Well, we have 2 and 2, 1 and 4. 2 plus 2 gives you 4, 1 plus 4 gives you 5. So I'm going to use a 4 and a 1. In order for them to be -5, they have to both be negative. So there's my second one factored. So once you're there, you have your 1 and your 2. You're going to set it up as 1 over 2. So we have 3x plus 4 over x minus 4 on top of x minus 4, x minus 1. Cancel out the like pieces. Well, x minus 4 and x minus 4 cancels out. So you get 3x plus 4 sitting on top of x minus 1. This would be what you would enter into your box. On number 4, we see, it says simplify the rational expression. It says x squared minus 121 over 11 minus x. Again, number it 1 and 2. So you're gonna work with number 1. It says x squared minus 121. This is a difference of squares piece. So you are gonna find the square root of 121. So I'm gonna write x plus 11, x minus 11. Then we go to number 2. And number 2 says 11 minus x. So I'm going to rewrite this to say negative x plus 11. And then I don't like the negative at the beginning, so I'm going to factor out a negative 1 out of both of them. So I'm going to write negative 1 parentheses, x is now positive, minus 11 on the inside. So we have our first one and our second one. Now you're going to put them 1 over 2. So we're going to have x plus 11 times x minus 11 sitting on top of negative 1 times x minus 11. And again, you're going to cancel out their like terms. So x minus 1 and x minus 11 and x minus 11. So we get negative 1 times x plus 11. You can enter it as this piece, or you can just distribute that negative in and type in negative x minus 11. You have 2 options to go into the box. So either or. On number 5, it says find the function value. So they gave us a function and they want you to find f of 4, f of 0, and f of negative 5. So basically all we're doing is substituting in for x. So on the first one, we're doing f of 4. So we're saying 4 plus 6 over 2 times 4 minus 1. So 4 plus 6 is 10. 2 times 4 is 8 minus 1. So we get 10 over 7. So the next one is f of 0. So we're going to do f of 0. So you're going to write 0 plus 6 over 2 times 0 minus 1. So 0 plus 6 is still 6. 2 times 0 is 0. Minus 1 is negative 1. So we get negative 6. And then you're going to do f of negative 5. So that's going to be negative 5 plus 6 over 2 times negative 5 minus 1. So I'm short 5, I found 6, I have $1. And then 2 times negative 5 is negative 11 minus 1. I mean negative 10, sorry, minus 1. So then we get 1 over negative 11. So in the first box, you're gonna write 10 over 7. In the second box, you're gonna write negative 6. And in the third box, you're gonna write negative 1 over 11. Okay, on number 8 is gonna be a multi-step problem. Number 6 actually is going to be a multi-step problem. So we have a rational expression divided by a rational expression. So the first thing we need to do is keep it, flip it, change it. So we're going to write the problem exactly as the first one is going to stay as is. Then you're going to multiply. The division becomes a multiplication, and then we're flipping the second fraction. So we're going to write the x squared plus 18x plus 81 in the numerator line, and then x squared plus 11x plus 18 in the denominator line. So when we get to here, you're gonna number it 1, 2, 3, and 4. So we're gonna work with 4 different problems and then bring it back together. So we're gonna look at number 1 first. So it's x squared minus 7x minus 18. Again, we need numbers that multiply to be negative 18. That add to negative 7. So I think of 9 and 2 of your times tables. The reason being is that 9 and 2 can get you to 7, but 6 and 3 does not. So that's why I went with these 2 numbers. To give you a negative 7, the 9 had to be the negative, and the 2 had to be positive. So we're factored out for number 1. Then we go to number 2. Number 2 had 2x squared minus 162. First thing I notice is that they're both even numbers. They're both even numbers, so you can factor out a 2 out of both of them. So you become 2 on the outside, and then we get x squared minus 81 on the inside, which again is difference of squares. So this breaks down further, so that we still have the 2, and then the x squared minus 81 becomes x plus 9, x minus 9. So we have our second one factored out. Here's the second one, here's our first one. Then we go to number 3. Number 3 happens to be x squared plus 18x plus 81. This is a sum of perfect squares because 81 is a perfect square root. So we become a 9 and a 9, because 9 times 9 is 81, and 9 plus 9 is 18. And then split your x's. Because it's a plus sign, we're plus for both. So the third one is factored out. Then we go to number 4. Number 4 says x squared plus 11x plus 18. So we need numbers that multiply to 18 that can add to 11. So I refer back to the one that we did before. 9 and 2 add to 11. So we become, I'm gonna write 9 and 2, x and x. Because they're both positives, then the 9 and 2 are both positive as well. So there's our fourth one factored. So now we've done our first, second, third, and fourth. And remember, our order was 1 over 2 times 3 over 4. And that's what we're going to do. So now we're going to set them up. So we have x minus 9, x plus 2. 2 times x plus 9, x minus 9. And I'm going to extend my fraction bar. I'm going to merge them all together. Then I'm going to do my number 3, x plus 9, x plus 9. And then our fourth one, x plus 9, x plus 2. And then what I'm going to do is I'm going to put a value of a 1 in the numerator line, just so that, remember, there is a coefficient of 1 there always. Okay, so now we're going to cancel out our like terms. X minus 9 and x minus 9 cancels out. X plus 2 and x plus 2 cancels out. X plus 9 with this first x plus 9 cancels out. The second x plus 9 and the bottom x plus 9 cancels out. And then when we look at what's left, it's the 1 I wrote over the 2. The rule is if everything eliminates from the numerator, it has to have a value. It's got to be a value of 1. So our answer is going to be 1/2. Okay, on number 7 it says perform the indicated operation. First thing you want to do is look at your denominators. The denominators are the same and they're being added together. So we're going to write one fraction line, x minus 2 is the denominator, and then you're going to write x squared minus 8x plus 12. Since the denominators are the same, we can combine them into 1. So then now we have a 1 and 2 situation. So we're going to work with number 1. Number 1 is x squared minus 8x plus 12. We need numbers that multiply to 12. They can add to 8. So remember, it has to multiply to 12 and add to 8. So I think of 6 and 2 because they multiply to 12 and add to 8. So I'm going to write an x and an x, 6 and 2. Now, it has to be a negative 8 when they add, so they need to both be negative. So there's the number 1. Then you go to the number 2. The number 2 just is x minus 2 and it stays x minus 2. So we go back to our line. You're going to write our 1, which is x minus 6, x minus 2. And then you're going to write your second one, which was x minus 2. And then cancel out what they have in common, which is x minus 2. So we are left with x minus 6. So our first one is our answer. We go to our number 8, which is add or subtract as indicated. First thing I notice is the denominators are not the same. So first thing we do is we need to figure out what our LCD is. So we're going to look at number 1. It says 7x squared minus 50x plus 7. So because the leading coefficient is greater than 1, we're going to go Columbian. So I'm going to write 7x, 7x, and then 7 times 7, that is 49. And has to add to negative 50. Well, 49, we have 7 and 7, and then 49 and 1. If I add 49 and 1, I get to 50. So I'm going to write a negative 49 and a negative 1. The first one can reduce by 7, so become x minus 7, and then the second one slides down. So that's the number 1 factor. The number 2 is x squared minus 4x minus 21. So it has to multiply to be 21, negative, and add to 4. Well, 7 and 3. I'm going to write 7 and 3. Now, in order for them to add a negative 4, the 7 has to be the negative and the 3 has to be the positive. So the second one is factored. So from these two pieces, we're going to come up with our LCD. Remember, LCD is least common denominator. So when we have bubbles, it's one of every type of bubble you see, one of every type, highest power. So x minus 7 is in both. I want x minus 7. 7x minus 1 is only in the first one. I still want it. X plus 3 is in the second one, but not the first one, but I still want it. So there's our LCD. So then what we're going to do now is we're going to write a fraction bar plus another one. And we'll write our LCD that we came up with underneath every single piece. 7x minus 7, x 1, and then x plus 3. 7. So I wrote my LCD. Now, when we look at our original had x minus 7, 7x minus 1. It's missing the x plus 3. So in the numerator line, you're going to take your numerator piece, which is 4x, and multiply it by what was missing. On the second one, it's missing the 7x minus 1. So I'm going to write 7x minus 1 in my numerator and multiply by what was missing from our piece, which is a 5. You're going to use your numerator times what you are missing. So now that because both fractions are the same, you can make it into 1. So we have x minus 7, 7x minus 1, x plus 3. You are going to distribute. So become 4x squared plus 12x plus 35x minus 5. When we get to this point, combine your like terms. So these two pieces can add together. So I get 4x squared plus 12 and 35 is 47. X minus 5 over our bubble piece, which is x minus 7, 7x minus 1, x plus 3. When we get to here, you want to know if you can factor this out. So what you're going to do is 4, you're going to do a little trick. You're going to say 4 times 5, that is negative 20. And it needs to add to 47. Factors of 20 that can get to 47. Well, 20 is 2 times 10, 20 and 1, 4 and 5. When I add 2 and 10, I get 12. 20 and 1 is 21. 4 and 5 is 9. You will never get to 47. So this is your factored piece. Okay, on number 9, it said simplify. First thing I noticed is a fraction plus a whole number, another fraction and a whole number. So first thing we're gonna do is we're gonna make them both fractions. So I'm gonna get 5 over 1, and then we have 4 over x squared minus 25 over 1. First thing is this what you need to do. Then you're gonna look at your denominators to find your LCD. So I circled all my denominators, and they all have x squared as the highest power, so LCD is going to be x squared. That is what you're gonna multiply every single one by. So we're gonna say x squared times 2 over x plus x squared times 5 over 1, x squared times 4 over x squared minus x squared times 25 over 1. Here, the x squares are going to reduce by a power of 1, so I get 2x. The x squares do not cancel, so I get 5x squared. On the bottom, the x squares cancel, I get 4. The x squared does not cancel, so I get 25x squared. Then, I notice that the numerator line, which is our number 1, can be factored. So number 1 says 2x plus 5x squared. They both share an x, so x came out, and I get 2 plus 5x. The number 2 is 4 minus 25x squared, which is difference of squares. So I get 2 plus 5x, 2 minus 5x. So that's what we're going to do for our line. We have x and then 2 plus 5x, 2 plus 5x times 2 minus 5x. So they cancel out and you're left with x sitting on top of 2 minus 5x, which happens to be D. Okay, on 10 it wants you to solve the equation. So again, notice that the denominators are different. So I'm going to circle them. Z, 3, and Z. So our LCD in this problem is going to be actually 3Z. So you're going to multiply that by everything. So you're going to do 3Z times 7 over Z plus 3Z times 1 over 3 equals 3Z times 3 over Z. The Z's are going to cancel out. So I get 3 times 7, that is 21, plus the 3's are going to cancel out, and I get Z times 1, which is Z, equals the Z's cancel out. 3 times 3 is 9. Since you want to solve for Z, So you have 21 plus z equals 9. Subtract the 21 over. So you get z equals negative 12. So our answer is going to be negative 12, option A. Okay, on number 11, sorry, it says solve the following equation. So again, circle your denominators. I get x and 16. So in this instance, our LCD is actually 16x. And that's what we're going to multiply each one by. So I'm going to do 16x times 1 over x minus 16x times x over 16 equals 0. So then the x's are going to cancel out. So I get 16 times 1 is 16 minus the 16's cancel out and I get x squared equal to 0. So when we look at the problem, we're going to do 16 minus x squared equal to 0. You can factor it. So you get 4 plus x and 4 minus x equal to 0. So opposite of positive 4 is negative 4. If I solve this one, set it equals 0 and move the x, I get positive 4. So you're going to be negative 4, comma 4. Remember, least to greatest. You could have also said, if you saw 16 minus x squared equal to 0, move the x squared over and said 16 equals x squared, and then taken the square root of both sides. So x equals positive and negative 4 as well, same answer. Okay, on number 12, they want you to rewrite this literal equation to solve for z. So first thing you're gonna do is find your LCD. So I'm looking at my denominators. I circled them, z, r, and v. So our LCD in this instance is z, r, v. That is what you're using to multiply each piece by. So zrv times 1 over z equals zrv times 1 over r plus zrv times 1 over v. So when the z's cancel out, we get rv equals, when the r's cancel out, you get zv, plus when the v's cancel out, you get zr. So the z's happen to be on the same side. So what we're going to do is we're going to factor out the z. So you have rv equals z times v plus r. And then you're going to divide both sides by v plus r. So z is the same as rv sitting on top of v plus r. So that's what this piece is, what you're going to write into the box, because the z is already embedded. On number 13, it says a person drove 200 miles in the same amount of time that it took a plane to travel 950 miles. Then they said that the speed of the plane was 150 miles per hour faster than this car. So car speed, I'm gonna label R. Plane is gonna be the car speed plus 150, because that's what it says, it's 150 miles per hour faster. So then they said same amount of time it took. So think of your distance equals rate times time formula and solve it for time. So I'm gonna divide both sides by r. So I'm gonna say d over r equals t. So what we're gonna do is the distance for the car over the rate of the car equals the distance of the plane over the rate of the plane, is what we're setting up for our proportions. So in this instance, the car was 200 miles at a rate of r that we didn't know. The plane was 950 at a rate of r plus 150. I'm gonna put that in parentheses. When we get to this point, you can cross multiply. So r times 950, that's 950r equals 200 times r, that's 200r plus 200 times 150, that is 30,000. You are then going to subtract the 200 back. So you get 750r equals 30,000. Then divide both sides by 750. So r equals 40. But the question didn't ask for r. The question wants us to find the speed of the plane. So remember that the plane was the car plus 150. So it is 40 plus your 150, which is 190. So for the box, the plane speed was 190. And then remember, this is a speed. speed is hours and miles. So miles is what we did for our ratio, miles over our hour. So miles per hour is our answer. On number 14, 14 is a calculator problem. You're gonna plug in parentheses, negative 343, because that's what we see inside the parentheses, and you raise it to, since the 3 is a cube root, it's an index of 1/3. When you do that, the calculator spits out the answer of negative 7. So negative 7 is your answer, A. So remember, it's asking you what number multiplied, that what index means, what number multiplied 3 times in a row is going to give you negative 343. Well, if you do negative 7 times a negative 7 times another negative 7, these two become positive 49. Times your negative 7, there's your negative 343. On 15, it wants you to do scientific notation. So when you take your number, so we have 66515. When they want it in scientific notation, draw a line between the first and second non-zero number. That is where your decimal point's gonna go. So now I'm gonna become 6.6515. And then you're gonna write times 10, and then there's a number that you're gonna write for the caret. So what you do is count the number of places you are after the line. There are 4 numbers after it, so I'm a power of 4. So this is what I'm gonna write in the box. Okay, on number 16, it says write it in positive exponents if possible. So here, first thing, you have your parentheses negative 64 raised to the negative 2/3 power. Put it over 1 so that you can switch the order. So it become 1 over negative 64, and now I'm going to be 2/3 power. So it says write with positive exponents. Simplify, and it said the word simplify if possible. So the numerator line is going to be a 1. We can see that. You're going to plug the second one into the calculator. You're going to plug in negative 64 caret 2/3. So then 1 is still there. And when you plug the bottom piece into the calculator, it comes out with 16 as an answer. So your answer is going to be 1/16. A is your choice. On 17, it says rationalize the denominator. So when you see 9 over 2 minus square root of 7, rationalize denominator means you need to multiply by the conjugate. So I'm going to multiply the top and bottom by the conjugate of the bottom. So I'm going to use 2 plus square root of 7 for top and bottom. So now we see a line 1 and then a second line. So we're going to work with line 1 first. Line 1 says 9 times the parentheses 2 plus square root of 7. So you get 18 plus 9 square root of 7. Then on line 2, you see 2 minus square root of 7 times 2 plus the square root of 7. Well, this is the same thing as saying a minus b times a plus b, or a squared minus b squared. The difference is squares. So when we look at this, the a position is a 2, which I'm squaring, minus the b position is a square root of 7, which I'm squaring. So we get 2 squared is a 4 minus square root of 7 squared. I'm squaring a square root, I just get plain 7. So 4 minus 7 is negative 3. So then now you're going to bring it back. So we have 18 over negative 3 plus 9 square root of 7 over negative 3. I wrote them as 2 separate fractions. So I can simplify. 18 divided by negative 3, that is negative 6. Positive and negative makes it negative. 9 divided by 3 is 3 with a square root of 7. So this is what I'm going to put into my box. Okay, on 18 it says solve. It says cube root of 2x minus 20 minus 7 equaling negative 11. First thing we do is need to add that 7 over to become cube root 2x minus 20 equaling, I had $7, but I'm short 11, I'm short 4. When you get to this point, it's a cube root. So to break that root, you need to raise it to the power of the index. So since it's a 3, I'm going to raise both sides to the power of 3. I become 2x minus 20 equaling negative 4 times another negative 4 times another 4 is negative 64. Then we're going to add 20 over. So you get 2x equals negative 44, and then divide by 2. So you get x equals negative 22. Now, normally you are required to take the answers and plug it back into the original problem to see if it checks. But because it's an odd index, no check required. So you're gonna write negative 22 for your answer. A is your choice. Okay, on number 19, it says a spotlight is mounted on the eaves of a house 35 feet above the ground. A flower bed runs between the house and the sidewalk, so the closest the ladder can be placed to the house is 12 feet. How long is the ladder needed to that the electrician can reach the place where the light is mounted? So first thing, here's the wall of the house. Here's your flower bed. Here's your ladder that you're putting on the eave. It says that the eaves of the house to the feet is 35 feet. So I'm gonna put 35 for my height. It says that from where they put the, okay, so I have my 35. From the base to the ladder, they said it's 12. And they wanna know how long the ladder is. So we're gonna use Pythagorean Theorem. So this is my A, this is my B, this is my C. A squared plus B squared equals C squared. So then we're gonna write 12 squared plus 35 squared equaling x squared. 12 squared is 144. 35 squared is actually 1225. When you add the two numbers together, you get 1369 equals x squared. And then you're gonna do the square root of both sides. So I get x equals 37. So the ladder is actually gonna be 37 feet in length. When we look at number 20, it says, write the quotient in form a plus bi. So first thing, I see 5 minus I over 6 minus 9i. You would need to use the conjugate. So I'm gonna use 6 plus 9i to both sides, top and bottom. So now I have a 1 and a 2 situation. So number 1, we have 5 minus I times 6 plus 9i. I'm gonna use the box for multiplication purposes. So we have 5 and negative I, 6 and positive 9i. So when we multiply, 5 and the 6 is 30, 5 and the 9 is 45 with an I, negative I and 6 is negative 6 with an I, negative times the positive, negative 1 and 9 is negative 9, but I and I is I squared. Then you need to remember that rule that says that I squared equals negative 1. So we see 30 plus 45i minus 6i minus 9i squared. And in place of I squared, I'm gonna write a negative 1. So we have 30 plus 45i minus 6i minus 9 times negative 1. So combine your like terms, simplify your powers piece first. So negative 9 makes it positive 9. So here's our like terms. 30 in the 9, that's your 39. 45 minus 6, that is 39i. So I'm gonna write that here. Then we go to the second part, number 2. Number 2 had 6 plus 9i times 6 plus 9i. Again, we see difference of squares. Here's A and B, A and B. That's my minus, and that's my positive. So they're opposite in sign. So you're gonna do A squared minus B squared. So you're gonna write 6 squared minus 9 squared, and then I'm gonna write I squared. The reason I did that is because of the sign change. So 6 squared is 36 minus 9 squared, that's 81, and I squared we know as negative 1. So we have 36 plus 81, that's 117. Well, 117, there's a rule. It says add the numbers and see if it's divisible by 3. So 1 plus 1 is 2, plus 7 is 8 and 9 if I add my digits together. So I can divide this by 3. So it's 3 times 39 gives you 117. So I'm gonna write 117 for both of them. And then because 39 goes into it, this becomes 1 over 3. 39 goes into it, becomes 1 over 3 with an I. It said to enter in the form of a plus bi, so this is how you would enter it into the system.